Unit 3, Lesson 5, Splitting Triangle Sides with Dilation. So we got to notice and wonder. So what do you notice and wonder? So here's triangle ABC with midpoints L, M, N. I'm going to go ahead and mark those. L, M, and N. Okay, so those are midpoints. N looks like to be the midpoint for AC. L is the midpoint for BC, and M appears to be the midpoint for AB. What do you notice? What do you wonder? So go ahead and pause the video, think about it, all right? And we'll see what we come up with. Okay, so hopefully you paused the video and you looked at it and you were noticing certain things. For example, I notice that we got the markings, right, for congruency, right, which means AN is congruent to CN. So that's something I've noticed. You could say the same thing with LC or CL to BL, right? And you could say the same thing about AM being congruent to BM. And that's because of the congruency markings. What else did you notice? Did you notice that maybe all four of these triangles exist within the same triangle, right? So triangle CNL, triangle let's see, LMN, triangle BLM, triangle MAN. They all belong to the larger triangle, triangle ABC, right? So they all belong inside. Did you also notice they all look to be congruent to each other? Like they all look similar in some way, right? I mean, we don't know about their lengths here, right? But they certainly do look similar. So if you notice anything else, let me know, because that would be interesting. All right, let's see. 5.2, dilation or violation. So here's a triangle, ABC. Points M and N are the midpoints of two sides. Okay, so they tell us for a fact these 2 points are midpoints, and they kind of back that up with the markings for congruency, right? Like N definitely cuts AC perfectly in half, as does M with AB. All right, so number 1, convince yourself triangle ABC is a dilation of triangle AMN. Okay, so basically they're saying you had this triangle, and then you did a dilation and got the larger triangle. Okay, that's basically what they're saying for number 1. So let's see. What is the center of dilation then? Well, M was here, now it became M. N dilated out and became C. So where do you guys believe your center of dilation to be? Okay, hopefully you said A, right? So point A is definitely your center of dilation. Well, what about the scale factor, right? K, what's your scale factor got to be? Well, they said here's a triangle of ABC, M and N and midpoints of two sides. Okay, well, M is half, right? N is also half of AC. So you had like 1 here, and let's say a distance of, I don't know, 1 here as well. They just became twice that, right? So I would say a scale factor of 2, right? Since M and N are both midpoints, which means they're half. They're in the middle, right? So to get them out there to become B and C, right, you have to multiply by 2. Okay, so convince your partner that triangle ABC is a dilation of AMN. And it looks like I already did that verbally, right? So M and N are midpoints are half of, let's see, AB and AC, right? Multiplying by 2 would get you out of that half, right? Okay, so let's go ahead and go to number 4. Convince your partner the segment BC is twice as long as MN. Well, I kind of already said it, right? So let's see. BC is twice as long. Oh, okay. I see what they're saying. So let me clean this up a bit. They're saying MN here is half of BC. So what would be your reasoning by that? It's a line, and we already said it goes by a scale factor of 2. So whatever your length was for MN, it has to be twice the length when it becomes BC. Because your scale factor, right, since your scale factor is 2 from center of dilation at point A, right? Okay, so that's my answer for number 4. All right, prove that BC is twice the length of MN. Okay, convince a skeptic. Well, I think I kind of talked about that in number 4, didn't I? So is there any other way you could have explained it? Let me know. All right, 5.3. A little bit farther now. Okay, so here's triangle ABC, which is the larger triangle, right? M is 2/3 the way from A to B. So that means AM is 2/3, BM is 1/3, right? And that's according to M. And then they tell us that N is 2/3 the way from A to C. So that's 2/3, and that's third in reference to N. Okay, so that's what they gave us. What can you say about segment MN, which is from here to here, compared to BC? So go ahead, pause the video, and come up with something that you can say the difference between those two, given what was given to us, right? Okay, so hopefully you pause the video and you realize that MN is probably 2/3 the length of whatever BC was, right? So let's see, MN is 2/3 of whatever BC is, right? Since, right, it looks like your dilation has scale factor of 2/3, centered at point A, right? Because both M and N head towards A, right? So I know that this point, point A, has to be my center of dilation. Okay. All right, so in summary, if we look at this example, all right, we have triangle ABC. There are some midpoints, right? So you have E being a midpoint of AB, D is a midpoint of BC, and we know because they're midpoints that BE has to be congruent to EA, right, which they already have marked here, and they also mark that BD is congruent to CD or DC. They also go on to say that segment ED is parallel to the third side of the triangle, So I believe they're talking about AC. So AC is parallel to ED. That's something to notice. So AC is parallel to ED. Okay, that's something important to notice. All right, and then they say, for example, AC is 10, ED is 5. Let's see, so ED is 5, AC is 10. So it looks like our scale factor halved itself, right? Like originally you're at AC, you were at 10. What scale factor do you multiply to get to 5? That's a half. Okay, that's how they got the scale factor to be at half there. Okay, so let's see. And the last little stage here is we have triangle ABC. Segment FG divides segments AB and CD proportionally. All right, so FG is right here. And they say it divides the segments AB. So AB is from here to here. And CB proportionally. Okay, so that means we have technically two triangles here, right? We have a smaller triangle, triangle BFG, right? Comparing itself to the larger triangle. Let me move it over a little bit. There we go. Triangle ABC. And they're basically saying that BG, right, which is this side right here, is going to be similar to GA. Okay, so this side is to that side, and BF, which is this side, should be to FC. Okay. So basically, this proportionality statement, and let me make sure I hit the head right on this one. BG, okay, is to GA, all right? They're on the same side, right? BG is a smaller, so smaller side to larger side. So this is like the small side to the larger side, or a small part to the larger part, all right? And then that is proportional to the other side, small part, which is BF, is to, let me guess, the larger side for that, or the larger part for that side. Okay, so it's like small to large, small to large. Okay, that's what they're saying in that proportionality statement. Okay. All right, that's the end of the lesson. Have a beautiful day.